Right, let's continue from our previous example. We now will discuss where the two axes of symmetry lie. We start by saying y is equal to x plus q. And we'll say y is equal to negative x plus q. This is the simplest way to find your axes of symmetry. Let's quickly do a recap. Our step one is to find the sign of a, to find whether the function lies in the first and third or the second and fourth. We then do our intercepts, y and x. And our fourth step is to find the asymptotes. So let's sketch the following with intercepts and asymptotes. So examining the standard form, we can see that you've got a positive 2 above the x, that's your a value, so it's greater than 0. So you say a is equal to 2, therefore we are sitting in the top right and bottom left, so the first and third quadrants, as positives always go in the first and third, negatives are second and fourth. Let's do our intercepts. We have y intercept where x is equal to 0. We've actually found the point already in a previous video, but because we're doing a recap, we'll quickly do it again. So g of 0 is equal to 2 over 0 plus 2. Now this gives you an undefined answer, so we know that we've got an asymptote instead of an intercept at x equals 0 because it's undefined. Let's do the x-intercept quickly. We've got y is equal to 0. We say 0 is equal to 2 over x plus 2. We solve for x. We've done this in a previous video, so you just take the 2 across, divide by 2 on both sides, times by x, and you get x is equal to minus 1. Your point is then minus 1, 0. And now let's do our next step, which is asymptotes. We wrote it as question or step 4, but we just did the x and y intercept in the previous step. So now we say when x is not allowed to be equal to 0, therefore there is a vertical asymptote at x is equal to 0. So when x is actually equal to 0, then y would be equal to 2. So your vertical shift upwards, which is your q, actually acts as an asymptote, if you want that answer very quickly. So that would be your horizontal asymptote, and then x equals 0 would be your vertical asymptote.